Hello everyone. Today we will discuss about relation and function. Relation, it is a set of ordered pairs. The first element of the ordered pair is called the abscissa and the second element is called as the ordinate. The set of abscissa is called the domain and the set of ordinate is called the range. We have different ways on how to represent relation. First one is arrow diagram. Through arrow diagram, you can easily determine if it illustrates a relation or function. Here are some examples. In this example, we can see that we only have two or more domains and we only have one range. And this example is called as many-to-one correspondence. Next example is the domain corresponds only to one range, and that is called as one-to-one correspondence. Next example is we have one domain corresponds to three range, and that is known as one-to-many correspondence. Another way is through ordered pairs. This is set of x and y pair. X is always the first element and y is the second element. In set A, we have 1, 2, 2, 4, 3, 6, 4, 8, and 5, 10. Wherein the domains are 1, 2, 3, 4, 5, and the range are 2, 4, 6, 8, 10. In set B, we have 1, 2, 2, 3, 3, 4, 4, 5, and 5, 6. Wherein the domains are 1, 2, 3, 4, 5, and the range are 2, 3, 4, 5, and 6. In set C, we have 1, 2, 2, 3, 2, 4, 3, 6, 3, 4, 4, 8, 4, 5, 5, 10, and 5, 6. Wherein the domains are 1, 2, 3, 4, 5, and the range are 2, 3, 4, 5, 6, 8, and 10. Another way is through tables and equation. The relationship between the domain and range can be illustrated using the table of values or equation. As an example, let's create table about the cost of number of buko pies if the price is 180 pesos. Let x be the number of buko pie and y are the price. So if we have one buko pie, the price is 180 pesos. If we have two buko pies, we have 360 pesos. If we have three buko pies, we have 540 pesos. And if we have four buko pies, we have 720 pesos. And if we have 5 buko pies, we have 900 pesos. From this table, we can create an equation y is equals to 180x. Next one is through graphs. Functions or relations can be illustrated through graphs. You can graph by plotting the points on the rectangular coordinate plane. You can take points from the set of ordered pairs, table of values, or equation, and vice versa. In this example, we have a table wherein x is equals to 1, 2, and 3, and y is equals to 2, 4, and 6. From this table, we can get the ordered pairs. First one is 1 and 2. Next one is 2 and 4, and then 3 and 6. Then connect the dots, so we have now the graph. From this graph and table, we have an equation y is equals to 2x. If we have a relation, we also have function. Function in arrow diagram ordered pairs, and tables, it represents a function if the domain is not repeated. In an equation in two variables, it represents a function if the exponents of the variables are positive integral exponents. And in graphs, it represents a function if it passes a vertical line test. In many-to-one correspondence, the domains are not repeated, so that it is a function. In one-to-one correspondence, again, the domains are not repeated, so that it is also a function. In one-to-many correspondence, we only have one domain and we have three range. It means that the domains are repeated, and that is a relation. Set A, we have 1, 2, 3, 4, 5 as the domain and 2, 4, 6, 8, 10 as a range. The domains are not repeated, so that it is a function. In set B, we have domain 1, 2, 3, 4, 5 and range is 2, 3, 4, 5, 6. Again, that is a function because the domains are not repeated. But in set C, we have 1, 2, 3, 4, 5 and the range is 2, 3, 4, 5, 6, 8, 10. And that is a relation because the domain 2 is repeated to the range 3 and 4. Another way is through equation. Function y is equals to 2x plus 5 and y is equals to x squared plus 4 because the exponent is an positive integral. Y is equals to square root of x plus 4 is not a function because it can be written as x raised. The square root of x can be written as x raised to 1/2. 1/2 is not an integer. That is a fraction. In y is equals to x raised to negative 2 plus 3, negative 2 is an integer, but it is not positive. In this graph, the graph and the vertical line has only one point of intersection. So that is a function. Next graph is the vertical line and the graph has two point of intersection. So that it is not a function. And in last graph, the graph and the vertical line has only one point of intersection. Again, that is a function. Remember, all functions are relations, but not all relations are functions. Thank you.